Our last question was from inequalities or linear programming. So it was very simple. If you want a full topic of linear programming, you can go to the playlists and please, you scroll down, you will see linear programming as our topic. So this one was saying the points P, Q, R, and S, S and T, are vertices of a feasible region. Show the feasible region on the graph with lines RS and ST as broken lines. Now, they are specifying RS and ST as broken lines. Find the two inequalities that describe the feasible region using PQ and RS, determine the maximum values using that equation. Now, here we start by plotting. So this is now my graph. You're supposed to use a graph paper on this number. So this now, for me, this is my graph paper now. I'm going to use it. I think plotting is very easy for everyone. Now we start. My point P is there, which is 6, 1. My 6, 1, I think you see. My 6, 1 is here. So this is my point P. Then I go to my point Q, which is 9, 4. For you, if you have a graph, it will be very easy. So this is my point Q. Now I go to my point R, which is 7, 8. 7, 8 is somewhere there. This is my R, 7, 8. Then I go to S, which is 2, 6. I think you can see where my 2, 6 is. 2, 6 is there. This is my point S, 2, 6. Then I go to my point T, which is 2, 4. 2, 4 is somewhere there. 2, 4 is somewhere there. This is my point T, 2, 4. Now, so that's now the first part. But you have not obtained all the marks. The next thing was to join, because we have to get a feasible region. You have to be careful. They told us that here, the only points which are broken, among the only lines which are broken, are RS and ST. So be careful. This is where our RS is. So my ST is broken. So I join them using a broken line like that. Then also, the other point which is broken is the point, the other line which is broken is ST. I look for ST there. My ST is broken, then RS. So also RS is broken, so I come and I join it as broken there. So after putting the broken lines, the rest are solid lines. So from there, you just join them, solid lines. So you are supposed to get a shape similar to a pentagon, though the sides are irregular. Anyway, so that is the first case. But now, before we get all the marks, we had to first also shade. Because this is our feasible region, it means that we had to shade outside that feasible region. So now, the last part was for you to show the shading. You don't need to shade much. That is enough. To shade, you show that you are shading both, all the lines in that order. So that's how we are supposed to get the 5 marks for our part A there. Then if you go to part B, they are saying, find the two inequalities that describe the feasible region using the line PQ and SR. First of all, if you want to get the line, it's in our part B, and then the line PQ. PQ has the coordinates P, which is here, 6, 1, and Q, which is 9, 4, as you can see there. So in order to get a line, we need a point where it passes, and also we need a gradient. So let us start by getting the gradient. Gradient between 2 points, we say y, x1, y1, x2, y2. So we say this minus the y, then 9 minus the corresponding y. This will give us 3, which is 1. So now we have the gradient of the line PQ. So we use y So putting in, you choose any. Let me choose this one. This y1 is now 1. Our gradient is 1 into x minus x, which is 6. You see here my line becomes y equals x. Then this will be plus to give me minus 5. Now that is the line. Now I need the test point to know the inequality. Is that my PQ is a solid line. So now using the test point, let me use a point inside the feasible region, not to confuse you. So 4, 4, I think you see 4, 4 is just here. It's inside here. So this one is going to act as my test point. So 4, comma, is going to act as my test point. Now testing which line? This one. So it's that from here, you see from my y, x minus 5. Now, I just substitute the y, the x is 1, the y is 4. Now, it's that I have y and negative 1. You see that trivially, our 4 is greater than negative 1. But because this PQ was solid, it means that now from this line I will get y greater or equal to, because our PQ was solid, x minus 5. So from this boundary line, we can get now our inequality like that. Then they are also telling us that SR, look at our SR. So our SR, it has coordinates S 2,6, then R 7,8. Now from there, you can ably see, still I get a gradient over, which would give me 2 up, down I'll be having a 5. So now I use the line. So now I use this one as my y, the gradient, x1, that point. Multiply through by 5, here 5, 30. By 5 here it will go to mean 2 times this, then a 4. So my 5y equals to x. When I take this 30 this side, I have negative 4 plus 30, which will give me plus 26. Now that is a boundary line, but I need to get the inequality, so I need to test. Let me still use the 4, 4, the point inside. So 4, 4, my test point. Always, I want always to use these ones inside our feasible region because for them they are direct. So now from my line, 5y equals 2x plus 26. You see my y is 4, so 5, 4, 2 into 4 plus 26. You see, when I'm substituting in the test point, I don't put any sign here because I'm concluding the sign after seeing the results. This is 20, this is going to be 8 plus 26, I think that is 34. You see that 20 is less than 24. So meaning that from my boundary line here, so my inequality there is 5y less. Now I'm not putting equal because SR is broken, so that becomes my inequality. 2x plus 26. So that becomes now my inequality for SR. Now, for part C, they want us to determine the value, the maximum value. Now I say, let my function, I'm going to maximize there, which is 2x plus 3y be that. Now, to easily know which point you are going to use, look out for these two. You see that x has a coefficient 2, but y has a coefficient 3. You see that of the two coefficients, y has the biggest value or the biggest coefficient. Now it means that the value that is going to give us a maxima is going to be the value of what, the point with the highest value of y. Now we also have a theorem which says that always The points that are going to give us either minima or maximum values are always at corner points. What do you mean by corner points? Corner points, these are the corner points we're talking about. So if I'm looking for a maximum value, I go for the highest corner. If I'm looking for the minimum value, in most cases I go for the lowest corner, or I check on these corners. Always, that's where we get the maximum values and minimum values, the coordinates. Now, from here is that because my y has the biggest coefficient, I look out for the highest value of y in the feasible region. So the highest value of y, the point with the highest value of y is going to be 7. So I mean it's going to be this 7, because you see I can't take 8 because 8 is there, is having a broken line. So the highest value of y here is going to be 7. So now I look out for the corresponding value of x here, which is going to be 7. So you see this point here is 7, 7. So I say using 7, 7. Why? Because it's the highest value of y I can get, because it has the highest or the greatest coefficient. So putting them there in my function, you see this is 14, this is 21, and when I sum, this one gives me 35. So therefore, my maximum value is 35, and so that's it. So that's how we handle that number. Please don't forget to subscribe to the channel. For more, please refer to the playlists. You will see now the whole topic of linear programming and everything I've been doing. So we are now going to start up to handle now the solutions for paper 2. That's it, members. Don't forget to subscribe to the channel.